know you said that you didn't understand these, although you were able to find them on Google. So I'm going to try to work them out. So the formula, sorry, I'm going to cross out your work because it's just distracting me. So this is the equation. So we want to factor out the common term. So that would be 2a. So then we're left with, like, basically pretend you're dividing everything by 2a. Since everything is divisible by that. So then we get a squared plus 2a plus 4. I did that right. So we are going to be using this table, which is from an earlier problem, and we're going to be looking at it to like find out how to write a quadratic equation. So basically, if you look here, there's 6 here and 6 here. And so this means that the point in between them is a vertex point. So we don't really know whether it's a maximum or minimum until we graph it. So I'm going to do one of the world's ugliest graphs, but we'll see. So -2, 6. So this is -2, and let's just say this is 6. So here is our point, and then in between here we have a -1 and an 8, a positive 8. So we can already tell it's going to be a maximum, but let's graph the 0, 6 here. So boom, this is our very badly drawn graph. So C is always the y-intercept. So we know that y equals ax squared plus bx plus, and the y-intercept is 6, because that's when x equals 0. And so in order to find the a and b, we have to start by, sorry, I sound probably really stupid right now. It's just I've never had to think about it backwards, but let's find the slope between 2 points. So we have, oh no, why is it doing that? No. Okay, sorry about that. We have -2, 6, and then -1, 8, and then x1, y1, x2, y2. So we do y2 minus y1 divided by x2 minus x1. So we get 2 divided by -1. So our slope is -2, which is equivalent to a, because a determines the width of our graph, and if you remember, the slopes rise over run, and so it basically will be the rise. Yeah. Am I saying that right? Yeah. Rise over run. So the width would be -2. So we have y equals -2x squared plus bx plus 6. So to get b, oh, 1 second. Okay, so to get b, I'm going to try to plug in an ordered pair. So I'm just going to go with -2, 6. So x, y. So y is 6 equals -2, and then x squared is -2 squared plus b times -2 plus 6. So this is 4. So 6 equals -8 minus 2b plus 6. So simplifying, we get 6 equals -2 minus 2b. Add 2 to each side. 8 equals -2b. So then we divide by -2 on each side, -2. b equals -4. So that is the answer. Sorry, I drew a blank, but y equals -2x squared minus 4x plus 6 is the correct equation given this table. I stole the table from the 2.4 problem, so you can double check that this is the correct equation by going up there. And as you can see, if this was worked out, it is that. Okay, thanks. Okay, to complete the square, the first step we're going to do is simplify a formula given. We're going to factor out 2, so we're left with x squared minus 16x equals 25, because we're factoring all of this. So x squared minus 16x, minus 8x, because we're dividing by 2. Minus 8x plus blank. Since we're completing the square, I like those blanks. So now we're going to, if you remember, this is b, and we want b divided by 2 squared. That is what completing the square basically means. So 8 divided by 4, which is -2, divided by 2 is -4, and then we square it. So that leaves us with positive 16, and so we add that to each side. And so x squared minus 8x plus 16 equals 41. So remember, what's in the square root is basically what the equation is going to be, x minus 4 squared. That is what this formula is simplified, or equation. So we're going to have x minus 4 squared equals 41. So square root on each side, and we get x minus 4 equals plus or minus the square root of 41. And then we add 4 on each side. So x equals 4 plus or minus the square root of 41. And that is our final answer. You can convert it to decimal places, but typically they just want this since it's going to be an ugly number. Okay, so this is similar to the other problem, except that under the parentheses, under the square root, it will be negative. So a equals 1, b equals 6, and c equals 11. So we just plug this into the formula. So -6 plus or minus the square root of 6 squared minus 4ac. So 1 times 11. So basically that is divided by 2 times 1. So -6 plus or minus the square root of 36 minus 44 divided by 2. So 36 minus 44 is -8. So 8 plus or minus, 6 plus, you get what I'm saying, divided by -8, You get it. I'm losing my mind silly, but it's fine. So this is 4 times 2 if you're thinking of perfect squares that can make it. So the 4 is the perfect square. So we're trying to get like the negative out of this. So it will be -4. So we'll take the square root of, this will be the square root of -4 times +2. So we'll get that -6 plus or minus, and then when we do this square root of -4, we get 2i square root times the square root of 2 divided by 2. So then simplifying, we would get -3 plus I square root of 2 as our final answer, plus or minus. Yeah. So that is how you solve it using a quadratic whenever it's negative in the parentheses and the square root. Now time to solve for the quadratic formula. So the quadratic formula is this formula right here. I will not be writing it out due to time sake, but it's a pretty important formula that you do have to memorize if you go into higher maths. So we're going to subtract 27 on each side to do this problem. Sorry for my messy handwriting, but basically this is A, this is B, and this is C. So we plug into the formula. We have -12 plus or minus the square root of, well, this would be a -12 because you can see B here is -12. Let me real quick write this just to be clean. So then we have -12 squared minus 4a, which is 3, times c, which is -27, divided by 2a. So simplifying, we get 1 second. We know this will be positive. So let me pull up the calculator. 4 times 3 times 27. 324. So that plus 144 is 468. Oh, divided by, no, dang it. Sorry. 2a. A is 3 in this case, so divided by 6. So simplifying more, we get 12 plus or minus the square root of 468 divided by 6. So now, is 468 a perfect square? No, it isn't. So there are a couple. We could leave it this way if it didn't want it to be simplified. However, I believe. However, we're going to simplify it because that's what they usually want. Factors of 468. Okay. So we're looking for the factors of 468 that would give us a perfect square. And so the one that, okay, I'm going to just write out all the factors real quick. So the factors of 468 are 1 times 468, 2 times 234, 3 times 156, 4 times 117, 6 times 78, 9 times 52, 12 times 39. Okay. 13 times 36. And then 18 times 26, I believe. 13 times 36. Yes. So we're looking for perfect squares. So I'm just going to do off the top of my head what I know is a perfect square. So 9's a perfect square. 36 is a perfect square. Those are the two and 4. But we want to go with the biggest one. So that would be this 13 times 36. So we do 12 plus or minus, and then since we know that this is the square root of 13 times 36 divided by 6. So we can take this 36 and move it outside once we take the square root of it. So 12 plus or minus, and the square root of 36 is 6. So, and then we leave 13. So then simplifying, we get that the quadratic formula, like the answer for this is 2 plus or minus the square root of 13. So that is our final answer for solving by using the quadratic formula. Okay, to solve by factoring, we basically think about this number and how we get it, and if it can add up to 11. So what are the factors of 28? So factors of 28 are 1 times 28, 2 and 14, and 4 and 7. So can any of these give us negative 11? Well, yes, one can. 4 and 7. So in order for it to be negative 11, though, each of these would have to be negative. So I'm going to take this down here, and so we're going to have, let me rewrite the problem real quick. Plus 28. So equals 0. We know that we can have the negative 4 and 7. So we can rewrite this as x squared minus 4 times negative 7x plus 28. Basically, we made it so this formula is expanded, where this is negative 4x plus 7x. Minus 7x. Pretty simple. Then, what we want to... Sorry, I forgot to put x there. So then what we want to do is factor out of here. So we factor out the x since that's the only thing they have in common, so we get x minus 4. Then this one, we can factor out negative 7, so we get x minus 4. These should always be the same. The next thing is you want to take what's on the outside of the parentheses, and that's going to be x minus 7. And you multiply it by x minus 4 since both of these are x minus 4. And this is basically how you can solve for it. So you set it equal to 0. So if you add 7 on each side, you get x equals 7. And then if you add 4 on each side, you'd get x equals 4. So this is a fairly simple concept. Okay, so we will be completing the square. Now, I don't know how complex your teacher wants it, but we will be doing a little bit of a complex problem since there will be imaginary numbers. But we have x squared plus 4x, and we wanted to get x by itself, so we subtract 8 on each side. So I'm going to leave this blank for completing the square, And what we do to one side, we must do to the other. So this blank just reminds us of that. So this is b. And when we're completing the square, we want to do b divided by 2 squared. This is why it's called completing the square. So we do 4 divided by 2, which equals 2, and then we square that. So it's basically 4. This is not usually the case. Just since 2 is an easy number, we're going to be working with it. So we add 4 to each side. So then what completing the square basically means is that you have x plus 2 times x plus 2, and it will give you this. So I'm not going to show that just for time's sake, but you can double check if you want to just by distributing. So basically that is also can be written as x plus 2 squared. So, and then we have equals -8 plus 4, so -4. So the next step is to square root each side when you saw by completing the square. So then we get x plus 2 equals the square root of -4. And so we know that this can't be good. So we have x plus 2, and then when we take the square root of this, it would be 2. But since there's a negative, we can't just do that. We have to write it as 2i. And then we subtract 2 on each side to solve for x. So then also remember there's a plus or minus when you do a square root. So we get -2 plus or minus 2i. So that is how you complete the square. Okay, so part 2 of 2.04 graphing quadratics, this formula right here, or this equation I should say. Now, it's hard to read this a little bit, but it looks like there's no squared. So this automatically means that there can't be a vertex. I have my retainer sensor right now. Everything sounds funny, but no vertex. So this was a trick question, sort of. But we can, so there is also no axis of symmetry, since there's just no really reason. So, we can find the domain and range, though. So, one second. Yeah. So, to find the domain, we have to think of a line. So this is basically 6x plus 5. I don't know why they wrote it like that weird. But domain is going to be, let's think about it. So if we draw a graph like this, and it starts at 5, it goes infinitely in both directions forever, then all x values will be covered. So the domain is usually all real numbers. Unless you get into higher math, then it's usually trickier. Then the range is going to be also all real numbers, or that notation, because it's infinitely going to be able to hit all the y points. And so this one's already solved pretty easily. It was a trick question, I believe. And it's not a quadratic graph. Quadratic graphs have to have the square.
Okay, so I will be solving 2.4 graphing quadratics. And so, number 1 is pretty simple, because it's already written in vertex form for us. So as indicated in the key concepts, this is the vertex formula. And so, over here, we can write this as x minus a -1, because that's how we got the plus, because it truly should be minus. And then we just have the rest of the formula as normal. And so, what this means is that -1 is h, and this is k. This is always means it's an important part. At this point, it's hard to tell if it's the maximum or minimum. So we have to find the x and y intercepts. So to find the x intercept, oh no, let's start the y intercept. So to find the y intercept, you do negative 2, 0 plus 1 squared. If you remember, that's how you find it because you're trying to find what y equals when x is 0. So then you have negative 2 plus 8, sorry for the rest. So the y intercept should be, positive 6. So on a graph that I will roughly sketch, oops, we have 6 here, and then we have this as 8. So we can already tell that this is probably going to be a maximum point, since these two, like, and then we're going to get an x value. However, let's define x though. So define x, y equals 0. So you get negative 2x plus 1 squared plus 8. So then to do this, you subtract 8 on each side. So negative 2x plus 1 squared equals negative 8. So then divide by 2.